Okay, so the other day we talked about stacks, and we took a look at a stack. And if I'm making some notes going back for stats for a stack, and I'm coming up here and I'm saying I need a little reminder, a little review for an array with stacks. Where did I add to it? I added to the
top.
well, I think of the array as horizontal though. Did I add to the beginning or did I add to the end? End, right? I added to the end, and then that was where I pushed, and then I popped. Where did I pop from?
The beginning.
Did I?
The end as well.
Also the end.
Still the end. Yeah, it was still the end. So remember, we didn't want to, as we added things to the array, we didn't want to have to worry. This thing at the front would be the very last thing we eventually got to, but we would add to the end and then pop from the end. So it was one of those we talked about. If it was vertical, I rotated it and let it fall to the right so that I add to the end and delete from the end. Okay. And then when I had a linked list, that was easier to work with. Where did I add with the linked list? Where did I do my insert? Where did I push? Where did I put it? Because on the test, you're going to have to write some code. So you're going to have to remember this. I'm going to say, because the queues are going to be exactly like a stack, except instead of last in, first out, right? So I'm still doing some review notes. This was last in, first out. This guy is going to be first in, first out. So when I added to the array, I added it to the end and I took from the end. With the list link, I added it to the beginning. Yeah. Oh, sounds like we have a new person here, Conrad, showing up. Add to the beginning, and then where did we take from? We also popped from the beginning. Okay, so just a little review, and I'm thinking it's good I brought up this little review because we may have needed it. Okay, the string, we added it to the end and we took from the end. The linked list, we added it to the beginning and we popped from the beginning. Again, it was dealing with the last one in was the first one out. So these guys were the same. So today, if I'm taking a look at a queue, okay, and I know that this is going to be FIFO. The first one in is the first one out. And again, we're going to look at it in the dynamic way with the linked list, and we're going to look at it with an array as well. Now, if I say, give me an example of a queue, and a lot of you were thinking, well, in Great Britain, they always use the word queue over in merry old England. And what is a queue? Give me an example.
I was going to say it's like a line when you're waiting at a restaurant or something.
Right. Grocery store. Grocery store checkout. The first one in is going to be the first one to get served. So in a grocery store, you have something along those lines. Like I tell the story way back when I was in college, we had a monitor and we didn't have hard drives and all that on our machines. We used punch cards and we sent them to the main server, and we had a TV screen with a queue. And, when you got in, it was the first one that was in is the one that got processed and or compiled next and was the first one out. We had this whole idea of this FIFO going on. And it happens a lot of time. What about in a grocery store in like the dairy section? They work behind the scenes, excuse me, and they have the milk that goes down like a chute. So the first one in, actually, when the user gets it, they pull from the front. It's the first one out. Some of you probably don't even go to a grocery store. I know Galen does because he doesn't have a choice because I see him at work. Okay, so now a moment ago, we just did a quick review of a stack, and we said we add to the end, pop from the end, and here we add to the beginning, and we pop to the beginning. And, you know, we used words up here like pop and push. Well, today we're going to use these words. We're going to NQ and DQ. Some people say deke, but I like DQ because I'm going to enter the queue and I'm going to delete from the queue. Okay, so if I come back up here and I wanted to make some notes similar to what I had up above with the stack for the array, what do you think I would add where and delete where? So if I'm thinking about an array and right now it's empty and I want to NQ the number 4, where would we put it? Well, I'm thinking we start putting numbers in like 4. Now, what are my choices for my next number? I could put it one of 2 places, right? Give me a place. Show me the money. Next number I want to enter is a 6. Okay, this is not a sorted list. Where would I put 6?
Spot 1.
I could either put the 6 here or I could put the 6 here. So my choices are, I could put it at the beginning or I could put it at the end. What do I know that I need to get rid of when I get ready to DQ? 4 would be the first one out. Let's not be thinking peanut butter parfait here with this DQ, thinking Dairy Queen or anything like that. All right, so I'm going to think on that for a second. And I'm also going to take a look at my linked list. If I have 4 in right now, and now I have a new node 6, where would I put it? In the beginning or in the end?
End.
Okay, so I hear the end. You know, again, my other choice is the beginning. So we need to take a little bit of an in-depth look at this and see which one are we putting where and so on. Again, my question is, I added to the end, I popped to the end for an array. What are we doing here? I add to the beginning and pop to the beginning here. Well, I will tell you that this one was both at the end. They were both the same spot because it was the last one in, first one out. For the linked list, it was both added and popped from the beginning. It was the last one in, the first one out. Here, I'm going to have a different order. So I have a feeling we may be doing the opposite, right? Wherever I add, I delete from the other end. Wherever I add, I delete from the other end. All right, so let's take a look at linked list, and maybe we can then come back up here and make notes as far as what we're going to do with an array. Okay, and then what we're going to do with a linked list. So let's say I have, and the first thing I want to do is NQ, okay? So I'm going to put a 3 in, and I don't know really what to do until I actually start playing with this. The next one is the 6. So let's see, my choices are leave the 3 alone and take out this and put the 6 in. And then when I delete something from the queue, I would delete the 3 and I would be left with something like that. Does that work for y'all? I heard one mumble over here.
Circular queue.
I'm sorry?
Probably not. We could do a circular queue, but I
Okay.
don't think that's what we're doing.
All right, so I'm going to say shh for right now, Conrad.
Okay.
So let's see. If I kept repeating this process, what am I eventually going to run out of? Okay, I'm going to NQ7. I'm going to NQ8. I'm going to NQ9. I'd now like to NQ10. And it looks like I ran out of room, which has always been my problem with the array. So what are some possible solutions here? Well, after I do 6, the first thing I might want to do is, so one option would be to do what?
Move 6 forward.
Yeah, one option would be to say shift left. You know, if I take something away, I DQ the 3. At that point, then I take everything in my list and shift it to the left. Oh boy, what if there's 8,000 things? Am I going to be spending a lot of time shifting? Yeah. So, again, I'm still working with, I have the 3, and when I enter at the end, and I'm thinking of the cashier standing here. 3's the first in line, and 6 and so on, and everybody moves up after someone's been taken care of. And that's this whole idea of what we're talking about with shift left. So that's an idea of shift left. Well, as Conrad mentioned a moment ago, we could have something called a circular array. And what we mean by a circular array is what happens if I put in 7, 8, 9, and now I wanted to go and use 10. Is there room in my array? Somebody say yes.
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 Yeah.
It's not necessarily at the end, it's at the beginning. So that's where this concept of circular array comes in. I need to bring this around to the beginning. Well, at the bottom of the page, you see I have some notes. And I have, when I have an empty queue, I have a variable named front, I have a variable named rear, and they're both set to -1. So by using 2 different variables, I could come up here and say, all right, this is my, oh, that's not an F. This is my front. Is it 0? Where would my rear be? Same place. So if I add an item to an empty list, front becomes, so I'm starting to put some pseudocode here together in my mind as I'm saying all this. I should be taking notes on how to work this. If I add something to an empty queue, front and rear both are -1. So I got that idea going of front and rear. And now every time I add something to the queue, oh yeah, remember this started there. Every time I add something to the queue, rear would get incremented. And rear would get incremented. So, rear right now is at 1 because I added something. And if I add this, it becomes a 2, a 3, a 4. So all of a sudden, I'm at the end. And what would I have to do if I'm at the end? Well, the next one would be some sort of wraparound. Maybe mod, maybe just saying size minus, a bunch of different ways to take a look at it. So when I'm thinking about working with MQ and DQ, and I'm going static, our choices were shift everything to the left. So the front is always 0, but the rear would move and just get subtracted by 1 every time we DQ, or use the circular array. Well, the one that gets the star is going to be the circular array. So some of my notes, I'm going to come back up here and I'm going to say, Shaka Khan, no eraser boogies. I'm going to say what? For an array, for FIFO, I'm going to add to the rear, delete the front. So again, when the test rolls around and you need to come up with this, you think of it as the grocery store, right? Somebody gets in line at the back, and then we're going to delete them for the front. That's how it's going to work for an array. Questions? Questions? Okay. So we are going to pause here, and hopefully I don't screw the video up this time. Recording. And we're now going to take a look at dynamic. What would we do here? So now I'm looking at an array, and I want to start asking questions like, Okay, it's a queue. Where do I add people? Where would I delete people from? Well, let's see. I'm calling my head pointer, I'm calling it front. We'll call this beginning of a linked list a lot of different things. We'll even give it the name root at one point. Okay. Right now it's front. And, so I have some people in the line. I have Mike and Bob and Beth in the line, and Mike's at the front of the line, and he gets taken care of. And well, let's do this first. Where would we enter someone new? So all of a sudden, Liz shows up. Where would Liz have to go?
The end.
The end, right? So I'm thinking along the lines of just like an array, I may need a way to track the end. How would I do that?
Would it be the one that points to null?
Well, not to null, but maybe to this guy, right? Because I don't think I want to traverse through to add something new in. That's an idea. If I only had a super small list, I could keep going until this pointer equals null, and then I could point that to the new node and the new node. But what happens if realistically in this world of working with big data, I'd have to traverse, and it might take a long time to traverse too. So just like we did with
Just have a pointer to the rear.
yeah, I think we're going to actually put another pointer in and keep a track of a pointer of a rear. So if I wanted to add something new, I take new node and say rear's pointer points to new node. And, oh, that would be kind of easy, wouldn't it? To add to the end. I mean, I'd have to check to see if it's empty first and take care of it that way. But otherwise, rear's pointer, rear gets the value, rear's pointer, I'm making a note, rear's pointer. All right, so let's stop being stupid, because rear's a pointer, and rear's pointer would get the value of new node. Would it be that simple? Yeah, because doing this with the is going to be much easier. What about if I look at the front with the linked list? I now have a new node. How would I deal with front? So this guy is going to go up here, my new node.
You could have
Wait a
front
minute,
point.
hold on a second. I'm talking and I'm not thinking. Don't even look. Don't even look at what I said. Rewind the video, 30 seconds. Go back. I'm adding to the rear. I don't know what I was talking about adding to the front. I'm adding to the rear. I'm going to DQ, delete from the front, because these are going to be opposites again. How would I delete from the front? And we're going to put a little more thought into this one. I mean, the simple response would be what?
Have front point to B.
Right. But here's what we're actually going to do. We're going to say temp pointer gets a value of front. Why would we do that? Front gets a value of front pointer. What might my next line be? Delete temp pointer. Okay, we're going to free up some memory. So now finally this delete comes into play, becomes important because these nodes could be huge and we want to delete it. So I'm going to put in a temporary pointer to what front points to, which is the M. Front gets the value of front pointer, so it now points to B, and then I'm going to have a delete to delete that temp pointer. Questions? Okay, I'm going to stop the recording now.